Okay, in this video I am doing a lecture for a class that I have to miss for MAE 3033 during the fall semester over Labor Day weekend, and so I have reserved the safety discussion of the DML, our Design Manufacturing Lab, for this lecture. This is the latest version of the shop rules as given to me by John Gage, and so let's start looking at the shop safety rules. First of all, DML was created to support manufacturing, design, and project coursework for all of CEAT, not just MAE. Okay, it has general shop facilities such as machining, welding, woodworking, those kinds of things, primarily for undergraduate students, but graduate students are allowed to use it. The DML is located at 1724 West Tyler. You should have all been to the DML by now. One of the reasons to know this address is if there was some kind of an accident, you could then give that address to the 911 operator. Turns out when you're a senior in aerospace engineering, you'll also use that address to get the pizza brought to the lab. Happens fairly frequently. Okay, general policy is this is a lab to support instructional activities, projects, and it's not to be used for personal projects or organizations outside of CEAT. Now, you can use it if you're on the Formula Car or the Baja team, but not for personal or hobby projects. Safety is a primary concern, and so we're going to try to keep you very safe. The shops are divided into a closed shop, room 126A, and an open shop. Okay, the closed shop has CNC milling machines, lathe, that kind of thing. The open shop is where you're working on your green badge. Okay, let's see. You are expected to have drawings or at least a very good sketch with dimensions of whatever you're going to be building out of the DML. That way, you should be ready to show that to any shop employer, shop personnel, TA, lab manager, etc. Okay, this says safety rules will be enforced by employees, staff, faculty, student technicians, and by students. So you should be enforcing any safety rules among yourself. If someone is violating a safety rule, let them know that and help them avoid violating those safety rules. Okay, we do use a name badge system, a shop certification system. The white badge basically you get once you finish the MSDS module, and that says you're ready to go into the shop and be trained. And after viewing the mill and lathe operation, then you'll be allowed to use the mill and the lathe to create some parts to earn your final green badge, which says that you've progressed to a level good enough that we believe you're safe, and we think you can make moderately useful parts, but most importantly, we believe you're safe. Okay, what to do if there are personal injuries? Okay. Let the DML lab manager know, or let one of his staff know, or let a faculty member know. There are first aid kits around the building. They have bandages, those kinds of things. There is a University Health Services on Form Road, which you could carry someone to, or you could carry them to the Stillwater Hospital, or you could call 911 if someone's in especially big trouble. If you are hurt in any way, there's some paperwork that you can get from the MAE office to document the fact that you've been hurt in some way. Okay, blood-borne pathogens. Everybody these days has to treat somebody else's blood as a deadly substance. And so there are special cleanup procedures. Generally let lab staff do those cleanup procedures, clean up, disinfect, those kind of things. If it's after hours, call this extension to get OSU Environmental Health Services, okay, and they could come over and clean up any possible blood. Okay, if someone is bleeding, get help to them. Then let someone who's trained clean up the blood. There are some places where you can eat and drink non-alcoholic beverages in the DML. There's no tobacco use of any kind within the DML. Okay, the drinks have to be limited to sort of what we call the break areas, or the non-operating areas of the machine shop. Of course, you all have cell phones. Set your cell phones to silent when you're going into the machine shop to keep from startling yourself or startling other people. Of course, no pets should be brought to the DML. Shop dress code, we actually talked about that a little bit. Okay, clothing and shoes. Okay, you're required to wear long pants and shoes that cover your entire foot, especially shoes that cover your toes. Okay, don't wear short pants or skirts, no flip-flops, sandals, house shoes, slippers, clogs, any other kind of open-toe shoes. When you're working around the machinery, long hair can be an issue, so you may not bring long hair, including ponytails or pigtails, around the machine. If you do have long hair, secure it in some fashion, such as tucking it under a cap, put it inside a shirt, clip it securely to your head so that your long hair doesn't become tangled in rotating machinery, leading to a very severe injury. You should not be wearing loose, floppy, especially long sleeves or baggy sweaters, those kinds of things. Long sleeve shirts need to be rolled up because those long sleeves can get trapped in machines and cause you some harm. Well, probably wouldn't kill you, but it might break your arm. Okay, old but serviceable clothing is recommended. Okay, so old clothing that gets the job done to protect you. Jewelry, no necklaces, chains, pendants, bracelets, etc. to be worn around the machines that could become entangled in the machine. Of course, you must wear safety glasses, and they'll match the ANSI Z87.1 1989 standards. They have to have side shields. Okay, there might be other areas where you were doing something like grinding, etc., where you would need more than safety glasses, such as a face shield, especially when welding. Okay, we in general will not be teaching you to weld, so unless you already know how to weld and know how to handle that equipment, we probably won't be teaching you. This is a map of the DML. In particular, it's showing you locations where safety glasses and workshop clothing must be worn. So D is the open machine shop, E is the closed machine shop, G and H are the welding and the woodworking areas. Let's see, and L is the aerospace lab, and Z is the machine shop area inside the aerospace lab. So you must have safety glasses and proper attire in those areas. Let's see. Every now and then, B, X, C, K, and F. B would be the low bay area. X would be sort of where that coffee break table is, right by the tool room. C is the, let's see, no, I said that wrong. B is part of the Formula Car room. Formula Car and many Baja rooms. BX. C is the low bay area. And K and F, let me find those. K is a room where we'll probably set up some workbench tables for you to work with later. When it becomes a busy work room, you need proper attire and glasses. And F, I need to find F. F is the high bay area. When you're working in there and it's busy, you probably need the right kind of glasses and clothes. Full face shields must be worn by anyone operating a grinder, but we'll see later it's very rare that we're going to let you operate a grinder. If you're doing welding, you need to wear a welding mask, welding screens. Okay, visual protection must be used to protect people who are just walking by. Okay, people walking past an area in which welding or plasma cutting is taking place should avert or cover their eyes, which means don't look at that bright light. In the event the radiation shield is not in proper place, don't look at it because it could actually hurt your eyes or cause blindness. Hearing protection. You need to wear hearing protection whenever the sound level is greater than 90 decibels, dBA. Okay, and a nice way to know about where 90 dBA is if you and someone are speaking and you're having to shout to hear each other, then the noise that you're in is probably greater than 90 dBA. Protection from dust and paint. We have dust masks. A disposable dust mask are available. Respirators are more effective than dust masks. You would have to provide that for yourself. Okay. If sanding is done to remove paint, okay, then that paint has to be tested for lead, and that's a royal pain. Okay. Any spray painting has to be done outside because any spray paint fumes will travel through the buildings, mess up the ductwork, and cost us a whole lot of money to have it cleaned up. If you're going to be leaving paint, you must bring the MSDS. We've already talked about that in the area of the MSDS. Okay, probably nothing to say there. Acquisition of storage of chemicals. Okay, so if you're going to be leaving chemicals to be stored out at the DML, then you must put labels on the container, you must get the MSDS and turn it in to the shop manager, and there are other paperwork that you must fill out if you're going to leave those chemicals there. Chances are you won't be doing that. Don't pour any kind of chemical down the drain. That'll cost us a lot of money. We mentioned in class that bottled gases must be kept secured so they don't fall over, break off the fragile part of the bottle, release a horrible chemical, and simultaneously turn into a rocket that can go through cinder block walls. Okay, that's what this all says. Electrical safety. This says it takes very little current to actually electrocute you. So some of the things you need to think about in the DML is grounding. If you're ever wiring up a circuit, then you need to pay attention to the grounding on that circuit and make sure that it is grounded properly. The use of electrical tools in wet areas simply is don't. Okay, now you use electrical tools probably in your bathroom all the time, and your bathroom is a wet area. But if you look carefully, there's a pretty good chance that on your bathroom wall, the electrical outlets have some funny looking apparatus in between the two electrical outlets, including a couple of buttons for testing and resetting a system. Those buttons typically return to something called a ground fault circuit interrupt that can interrupt the circuit before there's time for you to be killed by the electrical current. Okay, a bandsaw. Let me jump over and grab, I'm going to do Google on a bandsaw and bring a picture of a bandsaw over, and then we'll talk about it. Give me a moment. Bandsaw. Okay, and I'm going to go to images. Okay, and I will bring that over into our visual area, and let's see, this one looks pretty good, although probably the one we have is a pretty big one. It's maybe closer to this one. Let's take a look at this one. That's a bandsaw in one of the shops at MIT. Okay, that's probably not the best one. Let me go backwards. Bandsaw, images, and I think this one probably is the best one. We'll work with that. Okay, what you can't see is that there is a long continuous blade, saw blade, that moves up here, goes up and around the wheel, comes straight down through a gourd into the gap cutting area, and down through some bearings here to support it, down around a pulley that's probably powered by a motor, and back again, and that belt makes a complete loop. Okay, and the things we really want to focus on is power on and off. So there are easy to get to switches to turn it on and off. This blade guard is adjustable up and down. When we move it to its fullest height, then the blade is quite exposed between the top of the table and the bottom of the guard. The blade is just out there waiting for you to hurt yourself. In general, when you want to cut something, since this guard can be raised and lowered, raise the guard about an 1/8 inch above the height of the thing that you're going to be cutting, so that the thing you're going to be cutting will slide on the table and easily pass under the guard and allow the cut to happen. Okay, and then when you're done, lower the guard back down. So this is a bandsaw, and let's just take a look at the rules. Adjust the upper guide to about an 1/8 inch above the material being cut. Okay, there are various kinds, and they need various kinds of belt tension. Generally, don't adjust the machine if you think something is noisy or not cutting well. Ask one of the shop people. Okay, don't attempt to saw anything that doesn't have a flat surface to press against the table. If you're trying to use a bandsaw on a round shaft, that shaft can easily spin, and in the process of spinning, destroy the table saw, destroy the blade, and possibly hurt you. Okay, if you have scrap coming off the part that you're cutting, stop the machine to get the scrap out of the way. You can read the rest of these. Okay, we turn to a drill press. And so let me go back to Google, and I'll search for a drill press. Give me a moment here. That was odd. Okay. Drill press. Let's go to images. And let's find the good image. This is probably a pretty good one. Let's see what that looks like. Yes, I'll take that. Okay, this picture shows a floor standing drill press. This device is about as tall as I am. It's got a nice heavy base, a nice heavy round column. That round column has a rack in it, which is a straight line piece of gear. There's a table with a rack and pinion drive to move this table up and down. And then here is a chuck that's being held on this axis and spun on this axis. So there's a chuck that can hold drill bits to be used for drilling. Okay, some of the main safety things are, if you're drilling something fairly flat and thin, you want to get some clamps and clamp that stuff to this table, so that when you put your drill bit in here and you're drilling the hole, if the drill bit should catch in the material that you're cutting, then that nice flat plate that you might have set on this table loosely while you're drilling is grabbed by the drill bit and starts spinning very, very, very fast. Okay, and what happens is that sharp-edged plate is starting to feel more like a saw blade than just a nice flat piece of metal, and that saw blade could cut you up very badly. So make sure you clamp things to the table of the drill press. Okay, and then there's a chuck which will hold the drill bit. This thing will let the drill bit rise and fall, etc. That's a drill press. Let's move this back out of the way. Okay, let's see. The drill press has a thing called the chuck, and you probably used a drill in the chuck on the tail of a lathe. It'd be the same kind of chuck. It does have a key in it, and that key could actually fly, so you want to take that chuck out of the drill press. Take the key out of the drill press chuck. Okay, this says you need to clamp stuff. Okay, if you're going to be using a hole saw, make sure that that hole saw is not worn out. Make sure it's not getting too noisy or making a lot of smoke, those kind of things. That noise and smoke means something's going wrong. Talk to one of the lab staff people. We do have something called a sheet metal foot shear. Let's see if I can find a picture of that. Foot shear. And let's see what kind of pictures we have. We have some pretty good pictures. Let's see, let's drag this over here. And so looking at just about any of these things are basically a big pair of scissors for cutting somewhat thin sheet metal. This one looks a fair amount like the one that we have, and so you can see that there's a tabletop that's flat. You can set sheet metal onto that tabletop, push it into the vicinity of the location with the knife, make sure that it's positioned properly so that the knife will cut the material. And then this foot lever right here, you step on it with your foot, you push down, and if you have sufficient force, then a scissor like blade behind this guard will cut the material along a very good straight line, very much like a straight line scissor cut. This light piece right here is a clamp. When you step down here, this clamp pushes down hard against the table, so you don't want your finger under that clamp when you're pushing down. Okay, so watch out for the clamp, watch out for the cutting blade, and watch out for this stepping on here. And let's see, one of the big rules is only one foot stepping on here, only one person's foot stepping on this shear. So if we look at what that says, under no circumstances should two people stand or jump on it. Okay, tells you how to use it right here. Not only is there a foot operated one, but in the closed area there's a hydraulic shear. So same kind of shear, but operated by hydraulics. You can get one of the lab staff to help you use that. Striking tools such as hammers. There are lots of different kinds of hammers. They all have different purposes. The ones used for carpentry have a hardened flat face on the hammer, and that hardened face is designed to hit soft nails. Nails are made of fairly soft material. If you use a carpenter's hammer with a hardened face and you use it on something like a hardened chisel, then you're liable to start breaking off chips from the hard chisel. Will break off chips from the hard face of the carpenter's hammer, with chips flying out in any direction that could hurt you. Make sure you have glasses on and use the right kind of hammer. Excuse me. Okay, a metal lathe. Let's go back to Google, and I will Google a metal lathe. And we should have a good picture shortly, although it's taking a while. Taking a very long time. I'll make it a little bigger for now. I don't know why it's taking a long time. We'll click on images. There we go. Let's see. We've got what kind of pictures? We've got schematics. We've got actual photographs. Let's see. I would say that this one is not too bad. And let's drag it into the picture of the video. Okay, and this thing is, its width is probably probably longer than you are tall. This might be 6, 7, or 8 feet. And a lathe has several pieces to it. It has a spinning head that often has a chuck in it. It has a tailstock where the center of this tailstock is aligned with the center of this chuck. This tailstock is able to move left and right. This chuck is able to move in and out. You can lock the tailstock down at a certain location. And then there is our tool carriage. This carriage can hold a cutting tool, which can be moved left, right, and it can be moved in, out, any of those that you like. This thing may be multiple horsepower, so this thing is probably about chest high on most people standing next to it. This is a potentially very powerful machine, although this one may be actually kind of small. It just looks big and hefty, but they can be quite large. Okay, the purpose of a lathe is to grab material in this chuck, spin it, and then hold the tool in this tool moving device, and while the thing in the chuck is spinning, move the tool either in straight lines to make cylinders or slanted straight lines to make cones, those kinds of things. Or you can put drill bits into this chuck, and while the part's spinning, push the drill bit into the chuck and make a hole. So that would be a lathe. Let's take a look at what it says. We have different kinds of metal lathes in the DML. Okay, you're going to be checked out by an employee before you use one. Okay, the chuck on the lathe has a thing called a chuck key, and that chuck key lets you open and close the chuck and clamp parts into the chuck. That chuck key on the large lathes have large chucks have large chuck keys. Large chuck keys, if thrown somehow while they're still engaged with the lathe, could kill you or could kill somebody else. So never take your hand off the chuck key while the key is in the chuck, because if that lathe were turned on with the key in the chuck and everything was in place, the key could be forcibly thrown across the room and severely injure someone, maybe you, maybe your best friend, okay, or maybe a classmate. So keep that chuck key under control, then make certain that the thing you're cutting on the lathe is held very securely, so that that part that's spinning at high speeds doesn't come out and hurt somebody. Okay, never touch the chuck while it's rotating. Okay, there is a reversing switch that'll change the direction of the chuck. There's a brake that will slow the chuck down. Don't use your hand as a brake. When you're cutting soft aluminum and some other maybe soft steels, the material being cut will form very long, springy-like threads, okay, or springy-like pieces of metal that are very, very sharp. And so you want to make sure that you're not playing with that sharp metal, because they can definitely cut your hands, pull your hands back into the chuck. Probably wouldn't kill you, but it would hurt pretty bad. Okay, when you're using the lathe, if you hear a chattering sound or a squealing sound or other kinds of noise, something's probably wrong. Stop the machine and get some help. Okay, we've already mentioned mills, bench grinders, pedestal grinders, and handheld grinders. Okay, basically we're not going to allow you to work with grinders, because grinders have some special requirements for using them properly, and if you get them wrong, they could kill you. Okay, and here's sort of the story of how they could kill you. Grinding wheels are a very brittle stone material. Okay, so you need to wear a full face shield and safety glasses if you were to use a grinder, but we're generally not going to let you use a grinder. Okay, this wheel needs to spin up to a very high speed. Don't try to stop it and run at a lower speed. Number 3, the guard must be in place and the work rest must be adjusted properly. If you have questions, ask one of the employees. A bench grinder, pedestal grinder has a guard, typically clear plastic, maybe a clear hardened glass that you place between your eyes and the part being cut to keep sparks from flying into your eyes, that kind of stuff. Grinding must be done only on the face of a wheel, never on the side. Okay, and we're finally going to get to the big thing. Let's see, where is it? Okay, every wheel grinder in the DML is set up for grinding only ferrous or iron-based materials. Do not grind aluminum, copper, soft brass, other things like that, because those materials melt very easily and they then ooze their way into the surface of the grinder. And then after a little while, rather than grinding your material, you're just rubbing, say, old molten aluminum on new aluminum. And the only reason you're getting any material removal is material is melting and flowing into place. Now, what that means is you're forming an aluminum ring outside the perimeter of a stone disc. And that aluminum ring, when you get it hot, will expand faster than the disc. It has a greater coefficient of thermal expansion. And what goes wrong when the disc is powering everything all of a sudden appears to be too large, because that's another problem, but it's a mildly unrelated problem. And so you will find, let's see, sorry, let me back up a minute. What's happening here, this is really funny. You might even want to laugh at me. I will confess what's happening. It's been a long day. My mind wandered and I almost fell asleep in the middle of this lecture. So what we were saying is that aluminum on the outside of a disc can heat up and expand. It'll expand more than the disc, and it can cause that disc to explode and potentially kill you. Only use ferrous materials, not aluminum, copper, etc. That's all explained here. Woodshop has some of our most dangerous machines in there. Generally, you're not going to be able to use those unless you already have previous training by somebody else. But you can ask the lab manager or someone else to help you use those machines or to use them on your behalf. There is a computer lab. It's open pretty much 24 hours a day unless there's a scheduled class in there, which is very rare. So generally available to you 24 hours a day. Don't use it as a workbench area. Keep it clean and keep sharp metals off those tables. Okay, here is a map that shows the appropriate work areas. We will also set up in this room right here, room 129, some workbenches, and it will become an appropriate work area. The policy on forklifts is you're not allowed to use forklifts or any of the trucks in the machine. Only employees who have been trained and approved can use those. Okay, there's an online safety resource put together by Environmental Health and Safety that you can look at if you want any other additional information related to safety. So that ends this part. Let me now open the quiz. And so I will have these safety rules uploaded shortly. No, I already have them uploaded, and I have the quiz uploaded. So let me ask you on Wednesday to print out a copy of this quiz and take the quiz. And the quiz is open book, open notes, open neighbor, open video, open me, although I probably won't be available to you. But bring that class, this quiz to class on Wednesday of next week, because we're not going to meet on Monday, having already completed this, and then we'll exchange papers and grade it, and we will document that you have in fact known what the shop rules are. So this ends this video on shop safety, and we want you to have a very safe semester in our DML lab. We want you to be productive, being able to make parts that you need to make, but we also want you to be safe. That ends the video.